good morning, good afternoon, good evening. I see that we have people from everywhere, basically. Welcome to the webinar, Research Desktop, a remote desktop for computational and storage intensive research. It's organized by Cendio, ThinLinc, and ThinLinc HPC community. We'll talk a bit about what's happening today with a timeline. Everything initiated in February when a group of academics joined efforts to submit a BOF proposal to ISE 2020. Besides of the common interest for HPC, it was a wish to discuss the topic interactive supercomputers. The plans for ISE changed, but the interest in the topic remained. So as a consequence, the HPC webinars are now happening. We want to express our gratitude for the effort of these academics, as well as say thanks to Bernd Daman from the Technical University of Denmark, as he was the presenter during the first webinar in April, and we had around 30 attendees that time. So now it's the second webinar with Robert Henschel from Indiana University. We also thank you, Robert, for your support. I want to say thanks to all the attendees as well for your interest. And also explain that we got confirmations of representatives from industry, academia, and governmental organizations from several countries, as you see below. So thanks all of you for attending. We have here the short abstract that was sent to you previously. So about the topic, a remote desktop for computational and storage intensive research. Okay. Here comes the presenter of today's session, Robert Henschel, Director of Research Software and Solutions at Indiana University. And a short bio for Robert. As I understand, Robert wants to present himself in a more complete way. So some instructions for the webinar. We estimate a total time of 60 minutes with 20 to 30 minutes of presentation and the remaining time for discussion. If you have interest in continuing discussing after the 60 minutes, you are welcome to stay. The session is being recorded, but this will only be publicly shared once Cendio has the express permission from everyone that has been active in the session. So we invite the audience to turn off the microphone during the first part, that is the presentation, to reduce the noise pollution. If you have questions, you may raise your hand by writing in the chat your name, I have a question, or your name, and you can write directly the question as well. The moderator or the presenter will go back to you, so you can put your question. If you say it, remember to turn on your microphone. So during the discussion, we invite you, your active participation is welcome and enriches this moment that is, I believe, a very important part of this session. So you may contribute directly or write down in the chat in the same way as during the presentation. So, think now, Robert, are you there?
I am.
Okay, I think Robert wants to start the most important part, the presentation.
Thanks, Sean, for the introduction. And I also want to thank Bernd for presenting the last time. I think he did an excellent job kicking off the webinar series. If you are new to this one, by all means, have a look at the slides from the last one that you can either get from Bernd or from Cendio. I think he did a great job introducing the usage of ThinLinc at Denmark Technical University. And I'll try to connect to his presentation whenever I can in mine. So my name is Robert Henschel. I'm a Director of Research Software and Solutions at Indiana University. My job is basically to lead a number of teams that support our high-performance computing systems. We have a different team who operates those, and the teams that report to me are doing user support. We're doing deep engagements with faculty members to help them use those systems efficiently. We promote the HPC systems at the university. So I have a lot of interactions with users of our HPC systems, and the research desktop has really been one of my projects that I've focused a lot of my time on over the last couple of years. I'm also the head of the high performance group in SPEC, where we develop HPC related benchmarks, and I'm also active in OpenACC. So I want to give you a quick introduction to Indiana University, since not all of you are familiar with the institution, then talk a little bit about my thoughts on the overall concept of a research desktop, and then finish by talking a little bit about our interactions that we had with Cendio and the product team. And then we can come to the question and answer part. Last time we had a great Q&A part at the end. I think I learned a lot by the questions that I asked Bernd the last time and others asked. So by all means, if you have questions, let's do that in the Q&A part at the end. So Indiana is one of the states of the US. It's in the Midwest region. It's about, the university has two big campuses, one in Indianapolis, one in Bloomington. Bloomington is a good 4 hours by car away from Chicago. So it's in the Midwest of the US, and then about 2 or 3 hours away from Cincinnati. It's a beautiful campus. Bloomington itself is a college town. So you have a population of 70, 80,000 people, and a lot of them students. It's a great place to live. It's not an urban campus. It's more of a college town campus. The university is also reasonably large. It is the largest public university in the state of Indiana, with a total of about 93,000 students, 73,000 undergraduates, and 20,000 graduate and doctoral students. The university was founded in 1820. We're just finishing up our 200-year celebration. And the way the IT support is organized at the university, it's a central IT organization that I'm also a part of, with about 700 professional staff and about 500 part-time employees. And from those 700 professional staff, about 110 are in research technologies, which is the unit that I'm in. And research technologies is basically tasked with providing research computing support to all the faculty members and the students on all the campuses. Let me just talk a little bit about the history of computing at IU. I have another slide with all the systems, but the key is really there is a long history of providing research computing to all students, staff members, and faculty members at the university. It has started with the man in the lower left-hand corner, Marshall Rubel. He was a professor in astronomy, and he was the first person to run the Research Computing Center at IU from 1955 for, I think, 3 years until 1958. And he established a concept that we would try to make the computing resources available free of charge to everyone at the university. So the key for my teams is that we are tasked with not just providing support to high-end users that know how to write nicely parallel MPI codes or can take advantage of GPUs, but we're also tasked with supporting the systems for a very broad set of users from, for example, our Jacobs School of Music or the Maurer School of Law or our business school. So our mission is not just to provide HPC in its purest form, but it's also to figure out ways how we can make the HPC systems useful to non-traditional HPC disciplines. We have a number of systems. Our current flagship system is Big Red 3, which is a slightly older Cray XC30 with about 950 dual CPU nodes. We have a small GPU test bed with 36 2- and 4-way GPU nodes. And then we're just in the middle of installing our new flagship system, Big Red 200, which is the first academic Cray Shasta system that Cray sold with a planned capacity of 6 petaflops. It's a combination of the NVIDIA A100 GPUs that were just announced and the new AMD Rome processors. We also run a system for the National Sciences Foundation in the US called Jetstream, together with the Texas Advanced Compute Center, which is a production cloud environment. So it's an environment where people can basically use a cloud system like they would with Amazon or Azure to do scientific research, not to do research in cloud computing itself. So it's a production resource for science. Let me talk a few minutes about my thoughts on the research desktop overall. So at IU, we are in the unique situation where we want to make the HPC systems as broadly used as possible. And that really has implications, not just for how we make the services available, but also how we advertise them and how we configure access to the systems. When I look at the compute landscape at the university, as a researcher, as a student, I have a number of options where I can do computational intensive work. For example, everyone will default on starting out on the desktop or laptop. Nowadays, students are coming more and more with just an iPad or a Chromebook, which makes it far harder to run applications like MATLAB on those machines. Then there are a number of departmental servers or high-powered workstations that users can use. We have a Windows-based Citrix farm where we make some of our statistical and mathematical applications available. IU has a private cloud that is VMware-based, where people can buy or rent virtual machines and then install whatever they want and run it. And then we have the HPC systems and the Jetstream cloud. So when we look at the overall ecosystem, it's very diverse, but it's heavy on very end-user oriented user interfaces, right? So when you look at departmental servers or desktops, they are predominantly Windows or Mac OS on the laptops. So I'll take a small detour to illustrate that point. So when you look at the history of supercomputing, starting with the CDC 6600 at the top left, and then the Cray 1 in the middle, and then the Blue Gene Qs. So the systems have gotten larger. They still look more or less the same. And unfortunately, that's also true for how you access them. So you started out with green screens and terminals, and today, most of the HPC workload is still done in terminals. Granted, we have added color to the terminals, but coloring something doesn't make it inherently more useful for people who are specifically nowadays no longer familiar with something like a terminal or a command line interface. So when you look at the evaluation of desktop computing, right? It started out very much in the same way. I'm starting here in the late 80s, early 90s, where you had word processors that ran in text mode. And then word processors moved to Windows, to a windowing environment. And then, nowadays we run word processors in a tab in a web browser. I'm not personally the biggest fan of running stuff in web browsers, but it's the way desktop computing has evolved. So there is a large difference between how desktop computing has evolved and what users have grown up with compared to how access to HPC has evolved. Now, there are science gateways that abstract the usage of HPC systems very nicely, but they tend to be very domain specific, and they tend to be limited in the features that they offer for certain applications. So if you want to take full advantage of applications, you really have to do that in a command line driven way. So as Bernd alluded to in his presentation the last time also, he has seen a large difference in the skill set of new users. So I'm not saying that the high-end users of HPC systems have any issues using today's HPC systems. They of course understand how to use a batch system, how to do a remote, how to use a remote system, how to abstract your work in a shell script, submit it to a batch queue and wait for the results. But this is a huge challenge for new users. Getting people from the interactive concept of icons on a desktop of files that you no longer know where the location is, but you search for them, getting them into the concept of A, interacting with a command line environment, and B, abstracting your work into a shell script and submitting it is a huge task. At the same time, competing with the public relations department of cloud providers is really hard. Amazon, Microsoft, and Google do an excellent job in branding even HPC cloud computing as a very easy way. And for us HPC centers, we sometimes face, I face that a lot when I talk to professors and research groups on campus, where they say it's also easy in the cloud, right? Why do you make me go through all those hoops on the HPC center side? Well, you also pay for cloud computing to a large extent. You may not pay for the first year because of the incentives that are provided by cloud providers, but you will pay in the long run, and it's definitely not cheaper than running things on campus if the installation is large enough. So the other thing that HPC centers have to balance is convenience versus efficiency. Specifically, large HPC centers are evaluated by how much throughput they provide, how many jobs are they running, how many compute cycles do they provide. That is what funding are about from a metrics point of view, not necessarily convenience, right? If you can figure out how to get your users to use the system very, very efficiently, then you've done your job very well. On the other side, new users that are growing into this are not efficient users of those systems. So I think the challenge for us, specifically HPC centers that are slightly smaller, not the leading edge centers, but HPC centers that have to attract new users, the challenge is how can we provide something that is both compelling on a performance side and the convenience side. And while they are not mutually exclusive, they're certainly exclusive in some ways, which make it hard to provide an offering like this. So let me now talk about the project that we've been working on for a few years. And as Bernd pointed out in his presentation the last time, I mean, he has been working on this since, I think, 2006. So he has really shown a nice evolution of an environment that has had this kind of concept for a long time. We only started in 2015. And the idea of a remote desktop basically came out of a collaboration that we have with Guido Jukeland, who is also on the call, when he was at the CIH Center at the University of Dresden, Germany. When he was at the research visit, I asked him to evaluate some of the remote desktop solutions. So we looked at products like NX-No machines, DCV, and then also ThinLinc. And then later in the year, we started offering that as a closed beta to some of our users that we invited. And then we ran it as an open beta for almost 2 years. So we were very slow in making it a production service, but we really wanted to learn what do we need to customize with the service, how do we need to operate it so that it's most attractive to users. It became generally available in July of 2017. And basically, like a couple of months after we made it generally available, we rebranded it to the research desktop and made it a little bit more general. Over those couple of years, we increased our agent node count from 10 initially to 26, which is very close to the count that Bernd talked about in his presentation. Ours is done differently. I'll talk about this on the next slide. We upgraded from Red Hat 6 to 7, which also saw us move from GNOME 228, which is a nice, stable, but old environment, to Mate. We did a few custom development projects around cloud storage and graphical dialogues. And then we also introduced the web interface. So interestingly enough, when we started the service in 2015, we did not offer the web client from Cendio. We only offered the native client. So this is the workflow that I think everyone's familiar with. You have a laptop, you have a workstation, you SSH to login nodes of HPC systems, and then those login nodes are coupled to a cluster or an HPC machine, and you do the work on the login nodes, you submit it to the batch system, it runs. What we have done is basically in parallel stand up an environment around the research desktop, and I'll show the screenshot a little later in larger form, where users can use either the ThinLinc native client or a web client to go to that, and then we advertise them being able to do work on those nodes. So Bernd in his presentation talked about the concept of the application servers and the desktop servers. we have them all in one. So we have 26 servers, and we tell people you can run MATLAB on those machines, and the MATLAB or COMSOL or some of the other graphic applications, they will run straight on the desktop nodes. So we would rather provision a few more nodes than doing the application server concept that Bernd talked about. But those nodes are also submit hosts to one of our clusters. So you can go straight from the research desktop by opening a shell, and just you can queue sub straight from there. And then we've also provided a way how you get to the other HPC systems. Here are some of our policies on those nodes. We allow every user to consume up to 75 gigabytes of memory. The nodes that we have 256 or 512 gigs of memory. So if every user were to use its full 75 gig, we wouldn't be able to host a lot of users, but we're not seeing too many users consume this much memory. But most of the policies I describe are really centered on trying to provide a convenient environment. What we're trying to shoot for is give people an environment that is inherently better than what they can buy on their desktop or their workstation or their laptop. So up to 75 gigs of memory, which is a lot if you're using MATLAB, if you're using RStudio, that gives you a lot of room to grow. We developed a small custom C group script that can detect active versus inactive users on a node and can then dynamically limit the execution time. This allows us to basically fairly share a node between a number of active users that may not configure the parallelism in their application quite correctly. We allow for a long runtime of disconnected sessions. So in ThinLinc, you can configure the timeout of when a session is terminated, when a user disconnects. We have set this to 7 days. So you can basically log into the research desktop, run something, disconnect, and as long as you reconnect in the next 7 days, your session is right there for you. This is a huge boost to convenience. We've seen that in end user interviews. We've seen this in surveys that we've run. Users really like the ability to come back to their same environment. So not just that they run something, then disconnect while it keeps running and makes progress, but also they have a configured environment, they have an editor open, they have a shell session open, and they want to be able to not just drive home and then pick up work from home, or well, I guess nowadays you're working from home all the time, but the ability to come back the next day, right, and find the session readily available for you. We only support full desktops, and we only support 1 session per user. ThinLinc allows you to also publish applications. We experimented with this a little bit, but didn't use it in the end. And we started off allowing users to create multiple sessions. But that was confusing for us to support. It was confusing for the users. So we limit this to just 1. So a user gets 1 desktop on the system. They can do multiple desktops with virtual desktops in GNOME, but not through ThinLinc. We only support 1 desktop environment. So users log in, get Mate, and that's it. We've seen some requests for KDE applications, but not for KDE as a windowing environment. And then I strongly believe that an interactive system requires more care and feeding than a batch-driven system. So when we lose a node because of a hardware defect, and we lose all the sessions that are on the node, we will email all the users that had a session on the node saying, hey, we're sorry that we lost the node. Next time you reconnect, please be prepared that you find a new environment and not the running applications you had the last time. We've gotten very positive feedback from this, and this is something that we don't do in our batch-driven system, right? So if a user submits a batch job and one of the compute nodes that is part of that batch job dies, then the batch job gets terminated, gets an error code, and the user is ready to resubmit, but we're not sending specific communications out. We did some custom development around basically Sanity and rclone. Rclone is a cloud storage middleware that allows you to connect to a number of cloud storage systems like Box, Dropbox, Google Drive, OneDrive. We've implemented that on the research desktop and then used the mounting capability so that users can basically mount their Box share as a directory on their desktop. This is hugely popular because it offers a very easy way for users to upload and download files to cloud storage environments. It also offers plenty of opportunity to abuse the system, right? If you're running MATLAB against your Box directory, the fact that it works doesn't mean it works well, right? You still have a 50 millisecond latency between the research desktop and the cloud storage system, but it is very convenient for users. The same goes for the thin drive. We have a lot of users of the thin drive capability in ThinLinc in order to import and export files from the research desktop to their laptop or workstation. I'll talk a little bit about the custom desktop in a minute. And then we did a bunch of tools around Sanity. Sanity is a nice project from GNOME where you can drive graphical dialogues from shell scripts. So you can basically, instead of having to ask a user a question in a text application, you can hook up a nice GTK plus dialogue with a yes/no button, for example. And we've used that for things like request and help forms that will automatically create tickets in our queue. We have a batch system tool, and we have a tool that automatically submits an interactive job on our compute systems. So this is the desktop as it looks today. I'll just give a brief overview. Most of it is very self-explanatory. It's Mate, meaning it looks like GNOME 2, which has its advantages and disadvantages. We've specifically exposed the disconnect versus logout functionality at the top left, because we want people to know that you can disconnect from your session, right? You don't have to log out all the time, which is a concept that once people understand how this works, they're very happy with. We have the box folder, which appears to be once you've mounted it, it becomes a separate folder in your home, in your desktop directory, and then you basically just traverse your cloud storage that way. We have icons for the file browser, thin drives, and then our Scratch system directory. It is amazing to see how much more people are productive when they can actually copy files in a graphical tool from Lustre and GPFS file systems. It is really hard nowadays to get people to use things like tar CP on the command line. It's much easier for them to do that in the Nautilus acquirement, the Nautilus equivalent here on Mate. We have some icons for interactive jobs, the job manager, a terminal, and we have a folder where we basically have icons for all the other HPC systems. So if you open the folder, you get an icon for open a shell on Big Red 3, open a shell on Cars. So the systems that are not immediately login nodes on the research desktop are presented as separate shells. And so people can have a desktop with 3 shells on our 3 different HPC systems. And then just things like a feedback and question icon straight on the desktop, which reduces the barrier for people to ask us questions. This has advantages and disadvantages. Sometimes it would be good if people were to think about their question a little bit before they submit it. And maybe they think about it once they have to figure out what's the email address or the ticketing system. Here we get a lot of question, but it also builds a more personal connection with the users, which is really what we are after. For us to draw new users into the HPC system, we need to make it as convenient as possible. And then documentation itself, which is really just a Firefox link to our web-based documentation. Use cases. I have 2 more slides on this. I think it's very similar to what Bernd talked about in his presentation. Our biggest used applications are mathematical statistical applications, then graphical interfaces of HPC applications like the linear tools, debuggers, editors, Visual Studio Code, gedit, visualization applications, some computational applications that have graphical interfaces, COMSOL multiphysics being one, Schrödinger being another. We've built specific versions of our ThinLinc installation for data enclaves, where we implement specific security restrictions for restricted use data sets, but then still give it to them in a ThinLinc-like interface instead of having to use Windows with Windows Terminal Server, which is much harder for us to securely configure than a Linux environment. Easy access to compilers and editors for classes. We have some of the mathematics department professors who teach Fortran classes on the research desktop, and for them, not having to tell every student in the class to download SIGWin and then figure out how to compile simple Fortran applications in Windows is a huge time saver for them. Long-running data movement jobs, where people move things to our tape-based archive, or they move things around in file systems without having to do that in a job or running into issues on the login nodes where we restrict resource usage. And then a facility for For collaboration, we have a research group that has a very active outreach program to other research groups around the globe, Argentina, Europe, Japan, and they're all using the research desktop to basically connect back to IU and do the computational there. So for them to be able to have an environment that they can take home and then continue the collaboration without having to figure out how to how to create bidirectional affiliate accounts and how to use the one compute system over here versus there is very helpful. So this is just a slide of all the applications that we use. As I said, the statistical mathematical applications, SAS, Jupyter Notebooks, RStudio, and MATLAB are the mostly used applications. I'll speed up a little bit so I can finish in my allotted 25 minutes here. I'll show a few statistics. You don't necessarily have to read them. I just wanted to give you an idea of what kind of statistics that we are gathering for the system. The chart that I look at the most is the daily number of licenses, daily number of active users, and daily number of sessions. So what you can basically see is that we're just now, or a week or two ago, we hit a new high in our license usage. So we used a little bit over 300 concurrent connections to the research desktop with around 320 or so unique users in that day. And those 320 unique users had about 330, 340 sessions. So that's something important for us to plan on license count, and also shows us overall how the system is used. The little dips there are our maintenance days. So we do maintenance on the system about once a month, where we reboot the systems. So everybody has to get back on after maintenance. And it's astonishing to me to see how quick users are on those systems. We bring the system back from maintenance on like a Sunday evening, and within hours you have 50 users on the system, right? And a lot of those users maintain their active desktop connection for basically the next 30 days until we do maintenance again. It's a system that is really very quick to come back from maintenance. We're looking at HPC jobs submitted from the research desktop, basically trying to convert users from graphical interactive applications to using the batch system. We're looking at how long do those interactive jobs wait in the queue, because if you're in an interactive system and you double click the interactive job icon, you really want an interactive job quickly. You don't want to wait in the queue for 15 minutes until you get an interactive job. Then we're graphing some of the user impact events, like how often do users run out of memory? When does the out of memory killer come in and kill a user's processes? How often do our C groups implementation have to throttle users? Meaning, do we have to come up with different restrictions? Do we have to put more hardware in place? And then also killed sessions, which is the sessions that are killed because of inactivity. You see the spikes when there's a maintenance day, and we tell people to log out before maintenance day, but really no one does. So when maintenance rolls around, we just have to kill all those active sessions. But that's just a good way to get an overall quality estimate of how users are perceiving a service. We also track usage of the Sanity tools, which is it's not the most used tool on the system, but it's good to see how many users are using the tools that we wrote. Do we want to create more of those tools? Looking at the number of users daily, we have decided not to spend too much time on the tools because it's not really a lot of users. Okay, working with Cendio. I think overall, I'm very happy with the partnership that we have with Cendio. And I'm certainly not here to turn this into an advertising presentation, but we are 6 time zones away from Sweden, but we have very nice interactions with support. I very much appreciate the flexibility in Cendio with licensing, and from my point of view, the product is very reasonably priced, which is really important because as a university and looking at our financial constraints, we are very quick to build our own solution, right? So if the tool is too expensive, then we'll just develop a crappy solution and roll that out rather than buying a third-party software tool. The one deep interaction we had with Cendio was around two-factor authentication. IU started in 2016 to roll out two-factor with Duo as the two-factor provider. And then we made it mandatory for everyone by basically the middle of 2017. we've implemented that on our HPC systems by having a specific PAM module that interfaces with Duo. And the problem there is really the PAM module is very interactive. It asks questions during the authentication process. And the native applications from Cendio worked great with that, but the web client did not. So we reached out to Cendio in March 2018 saying, hey, this is great. We have to do two-factor here, but your web client doesn't support it. We came up with two plans. One is to implement two-factor, and specifically two-factor for the way that we use it, right? So don't get me wrong. This is not if you do it through RSA where you append your key to your password. That's something that worked fine in the web client. But our two-factor was very interactive when it comes to asking questions during the login process. So we came up with two solutions for this. And then we were fortunate enough that we had a conference that several team members of mine attended in Stockholm in May of 2018. So we actually met with Johan and Pierre to talk about the requirements and also give them a little bit more feedback on here's what we use the product for. From what I could tell back then, I think HPC was not really a focus area for Cendio. They had a number of HPC customers, but it was not easy for them to understand what the HPC use case of ThinLinc is. So we then tested nightly builds, and then basically a couple of months later, the web interface supported the way that we run two-factor authentication. The only downside was there was really only one release of ThinLinc in 2018, and that was in May. And then we basically had to wait until the production release came out in March of 2019 before we could switch to two-factor, because we were not confident that we wanted to run our production system with a nightly build. So that may be the one criticism there is a little bit more timely release would be nice. But overall, submitting the bug, dealing with Cendio on the bug, providing information was very straightforward. And just another graph on statistics. This is our monthly unique users. So in the last couple of months, we had over 500 unique users on the system, and 120, 150 of them used the web client. So it's about 20–25% of our users are going into the system through the web client. I personally always advocate for installing the platform-specific client because it has so many more features. But if you want to check on your computation while you're on a Chromebook or an iPad, then the web client is the only way to go. So to sum this up, this is a very interesting project for us. It is now an integral part of our IT and HPC infrastructure. It is our go-to solution to onboard new users to the HPC systems. It's fully accepted by the users and by us as a resource provider as well. There was large debate on whether we wanted to roll out a system like this, but now it is really an important part of the infrastructure. It has attracted a lot of new users and has made things possible that were very hard to do, at the least, in the HPC systems before. And working with Cendio through this process has been very straightforward. And they've been a great partner. Thank you so much for your time. Sorry for the talking a little fast and covering a ton of slides.
So presentation is done. Discussion as well. I want to say all of you thanks for joining this webinar. We hope you had a good session, and we make the question, would you like to present your ideas? You are welcome to join the community and share your thoughts and feedback with us. So you have Aaron's email and mine here. Feel free, you are welcome to contact us. Thanks everyone.